Hello everyone, as we are entered question 3 of topic 3. So the topic is solution of homogeneous differential equation. Now the question is solve x square plus y square dx equals to 2xy dy. So the first step of homogeneous differential equation process is to find out whether it's step 1 is to find f of kx comma ky equals to f of x comma y. So let's substitute f of kx comma ky in f of x so that we should get same f of x comma y. If it is same, so the step 1 is accepted and that will become a homogeneous differential equation. So let's start substituting f of kx comma ky in f of x comma y, where f of x comma y is dy by dx. F of x comma y equals to dy by dx. Now dy by dx, this dx goes this side, as it is multiplicating here, it goes there and it divides this. Dy by dx is equals to x square plus y square divided by 2xy. As this term is multiplicating here, it goes there and it divides this term. So that becomes dy by dx is equals to x square plus y square divided by 2xy. That's how we have got f of x comma y equals to x square plus y square divided by 2xy. This is the thing we have got. So the step 1 is to substitute f of kx comma ky in f of x comma y. If we get f of x comma y equals to f of x comma y, then we can accept it as homogeneous differential equation. So let's start substituting f of kx comma ky is equals to k square x square plus k square y square divided by 2 into kx into ky. So in numerator I can pick k square common, k square of x square plus y square divided by 2 into k square xy. So k square and k square gets cancelled, then it is x square plus y square divided by 2xy. We got the same things here. F of kx comma ky equals to f of x comma y, right? Then we are supposed to write this statement: f of kx comma ky equals to f of x comma y. As we have attained step 1, f of kx comma ky equals to f of x comma y, we do accept the thing. It is a homogeneous differential equation. So let's start accepting. So the given differential equation is said to be homogeneous differential equation. Now as we attain step 1, we start moving to step 2, that is putting y equals to vx. So before putting y equals to vx in the f of x comma y term, so let's start differentiating this equation. So let's mark this equation as equation number 2. So differentiation of equation 2 with respect to x. Differentiation of equation 2 with respect to x. So we get d by dx of y is equals to, so as we know that we put uv formula here, that is d by dx of u dot v equals to u into v dash plus v into u dash. So u into v dash, that is v, u is v dash d by dx of x is 1 plus v into u dash, that is x into dv by dx. Yeah, so the term will be dy by dx is equals to v plus x into dv by dx. So let's mark this equation as equation number 3. Let's put the box over here so that you can identify easily as this is formula. Yeah, now using 2 and 3 equations in 1. So what's the one actually? One is the term which is f of x comma y, right? That is f of x comma y is equation number 1. This is the first equation which we have formed from this. So let's start. So where we do have the equation 1, that is dy by dx is equals to x square plus y square divided by 2x square. So we have to place vx in place of y, right? So we should also replace the dy by dx term with this. So it becomes e plus x into dv by dx, that equals to, as we are mentioned to put vx in place of y, so no need to disturb x term, x square plus vx whole square divided by 2x into vx. So now let's start simplifying this term. V plus x into dv by dx is equals to, so I can take common of x square here from the numerator. It becomes 1 plus v square, right? Then from denominator also we can take x square common. This term leads to this thing. From this thing we can take x square common. So the leftover term here is 2v. So let's start cancelling x square terms. So now we do have v plus x into dv by dx is equals to 1 plus v square divided by 2v. So now the third step is to segregate v terms and x terms. So it's the beginning of variable separable method. So let's apply variable separable method. Now the step is step 3, which is variable separable method. That is to separate x and y terms, or we do have here v and x terms, right? So x and v terms, so let's start sending v term here, and let's remain this term same here. That becomes 1 plus v square divided by 2v minus v equals to dv x into dv by dx. So I have start separated this v and x term here. Then the next step is to take LCM here. LCM of this term is 2v. So I have taken 2v as LCM. So after taking, this term remains the same, 1 plus v square. So here after minus I will start multiplying this with this. That leads to 2v square. 2v square. 2v into v. 2v into v is nothing but 2v square, right? 2v square. So this term I have got through this. So this term remains the same here. So this term leads to 1 minus v square divided by 2v equals to x into dv by dx. As this term has no modification, we simply put here. So the thing is minus 2v square plus v square is minus v square. That is minus 2 plus 1 leads to minus 1, which is minus v square. So now let's start separating or segregating it x and v terms. So separating is nothing but moving v sides aside of equal to, and x terms aside of another side of equals to. So now the v term is actually here, so let's send this here. So when we cross multiply the thing, it goes down, so which will become whole divided by that tends to 1 minus v square divided by 2v, which is again whole divided by dv, that equals to x divided by dx, as this is the term which is the whole numerator thing. Now as we have shifted dv here and we have kept x term here, the same thing the term is which is over here. Now let's as dv and dx, both the terms should not be in denominator, so let's send them up. So how the sending is possible is like reciprocaling the terms which are right towards the equal to and left towards the equal to. That is dx by x is equals to dv, which is whole divided by 1 minus v square divided by 2v. Like flipping this term and flipping this term at a time. The thing which is to remember is flipping this term and this term at the same time is important. Same time. So after flipping, which is done in the same time, we got this thing. So now as we can see this term here, so I'm just again sending it to numerator. When this thing goes to numerator, we take again reciprocal of this, so that becomes 2v divided by 1 minus v square into dv. Next, the simple thing, 1 divided by x into dx. The thing we have to remember is dv and dx should not be in the denominator one. Now let's start integration, that is integrating or integration on both sides, that is now from previous problem we saw that integration of 1 by x leads to log x. This is the formula which we need to learn, which I have posted in shorts. So it was my first video, so take help of that to learn this integration formulas. Now let us solve LHS part firstly. We do get log x, that equals to, now let's sort this. Now we do have a popular formula, that is famous one, that is most important one. This one is f dash x divided by f of x into dx. What its integration of this thing is equals to log of f of x. This one is the important formula which we need to learn. It's a very and very most important formula. I think we should match most probably 90% of sums in M2 with this in chapter 1 most probably. So now, so derivative of this is minus 2v. So simply putting minus over here, as we have got this formula here. So before this thing we have to place minus simply. that is log of 1 minus v square plus c. So now putting minus and getting this is simple. Only minus is missing, right? So we have kept minus here. Remaining rest of the thing is same. As we can apply this formula for this, the rest of the thing is simple. So now the thing is c equals to log c, which is log c can be also called as c, as log of constant tends to c, which is another constant. So now log x plus log of 1 minus v square is equals to minus log, plus log c only, log c. Now we do know the formula log a plus log b is equals to log of a into b. Just log of a into b. So log of x into 1 minus v square equals to log c. As we can see, log both sides of equals to, let's simply cancel it. So we do get x into 1 minus v square is equals to c. So the last step of this problem is to keep v as y divided by x. So as we have v equals to y divided by x, so let's start extracting v value. That tends to v equals to, sorry, equals to vx, y equals to vx. So when we start extracting this value, v equals to, so we get v equals to y divided by x. This is the last step. So simply putting v value as y divided by x square equals to c. So this is our final answer. So putting v equals to y divided by x, this is our last step in homogeneous differential equation process. So here I have displayed whole solution together. I do hope I have conveyed the concept. So please like, share and subscribe.